Hello friends, welcome back to my channel. In this video I am going to discuss about temperature dependent of resistivity. Clear? Previous video we discussed about the resistivity. In that the resistivity variation with the material to material we discussed. There we studied that resistivity is lesser for conductor, next alloy, next semiconductor, next insulator. That means the resistivity is larger for insulator. Now we are going to study what is the variation of resistivity with the temperature. Okay, so I am going to take some assumptions. Rho T1 is the resistivity at T1 temperature and rho T2 is the resistivity at T2 temperature. Okay, then what is the relation with this? Means rho T2 is equal to rho T1 into 1 plus alpha into T2 minus T1. Clear? This is the formula for resistivity at a particular T2 temperature. Okay, clear? This is the, from this, what is rho T2? Rho T2 is the resistivity at T2 temperature. Rho T1 resistivity at T1 temperature. Alpha is a new term. This is the temperature difference. What is alpha? Temperature coefficient of resistivity. That is about alpha. Clear? Temperature coefficient of resistivity, and this temperature coefficient is to be constant for a particular material. Okay, then we will see what is the temperature coefficient of resistivity formula for the alpha. Clear? Okay, then this equation, if you multiply with this, what you will get? Rho T2 is equal to rho T1 plus alpha into rho T2 minus T1. This will come to this side. What you will get? Rho T2 minus rho T1 is equal to alpha into rho T2 into T2 minus T1. What we need? Alpha. Remaining term come to this side. So alpha is equal to what you get? Rho T2 minus rho T1 divided by rho, sorry, this is rho T1 because we are multiplying. Rho T1 T2 minus T1. This is the formula for alpha. Clear? This alpha is to be constant for the particular material. Okay, then next we will see about the resistivity variation with the each material. For conductor, what is the thing? Like this we say. Okay, for first we take out the conductor. For conductor, we are going to take it as the resistivity versus temperature graph. Resistivity versus temperature graph. If you draw this graph, we will get the graph like this. That means what? The temperature increases, resistivity increases and reaches to a. Okay, so why this is to be happening, we have to explain. So we can say that for conductor, resistivity increases with increase in temperature. Increase in temperature. How this is to be happening? Okay, so we know a formula. Resistivity rho is equal to m by n e square tau. Based by using the drift velocity, we derived this formula. In this, m is the mass of the electron, E is the charge of the electron, N is the number of electron per unit volume, and tau is the relaxation time. For a conductor, already the valence electron came out from the atom. So even if you increase the temperature, that means if you give some energy, heat energy, then only the temperature is increased. If you increases the temperature, number of electron per unit volume is not to be increasing. So m is mass of the electron, that is a constant, n is constant, E is to be constant. So the only one factor is tau. Here what is tau? The relaxation time, that means the time gap between separate collisions. So when the temperature increases, the electron got the energy, so it is very fast to move and it will be strike and collide very fast. That means time gap between the collision is to be smaller. So for conductor, tau, what happened? This variable becomes smaller. If this is to be smaller, what about rho? Denominator is decreases, rho will be increases. So we can say that the tau decreases, rho value increases. This is the reason for the case of the conductor. And what is the alpha value for a conductor? Alpha formula is rho T2 minus rho T1 divided by rho T1 into T2 minus T. Clear? Okay, so I am considering as T2 is greater than T1. If T2 is greater than T1, what we will get? Rho T2 is greater than rho T1, because when the temperature is increased, the resistivity increases. Alpha is directly proportional to, we can take that alpha is directly proportional to what? Rho T2 minus rho T1. What about this one? The rho, this is to become a positive value. So what we'll say? Alpha is to be positive. So we can say that temperature coefficient is to be positive. So for conductor have positive temperature coefficient. Temperature coefficient of resistivity. Okay, why? What is the meaning of it? Alpha is positive, temperature increases, resistivity increases. That is about the one conductor. Now we are going to see about insulator. What will be happen for the insulator? Clear? Or semiconductor. What will be happening for the semiconductor? Okay. So for the semiconductor. Semiconductor, temperature versus resistivity versus temperature graph. We will draw resistivity versus temperature graph. If you draw it, we will get like this. That means when the temperature increases, resistivity comes down. Okay, so we can say that for semiconductor, temperature increases, resistivity decreases. Conductor, temperature increases, resistivity decreases. We have to say why it is. We know a formula. Rho is equal to m by n e square tau. Here, what is semiconductor material? Semiconductor material will conduct if we will give some initiation. That means if we will give some energy. What about this n value? This n value will increases. This n will be increases. This increase in the n will compensate the increase in the tau. Tau will be increases lesser. So n will be increases. So what about the denominator? Denominator will be increases. So the rho value will be decreases. So the resistivity will be decreases for increase in the temperature for semiconductor. Clear? And what about the sign of the alpha? We'll see. What is alpha? So what is this? Is alpha. I am taking if T2 is greater than T1. What about rho T2? Rho T2 is less than rho T1 because temperature increases, resistivity decreases. Alpha is directly proportional to rho T2 minus rho T1. So this is, you will get as a negative value. So what we can say that? Temperature coefficient of resistivity for semiconductor is negative. Alpha is negative. That is about a semiconductor. Okay. Now we will see about a special type of materials, that is nichrome, manganese and constant. Okay, so we'll see about nichrome. Okay, nichrome is what? It is an alloy. Okay, nickel, chromium, iron. This is a combination of this metal alloy. So we will see the resistivity versus temperature graph. Resistivity versus temperature. We'll get the graph is like this. Sorry, that means we can see that this is the, that means when the temperature increases, resistivity is almost constant. Okay, that means this substance resistivity is not dependent upon the temperature. Okay, so resistivity is constant. Okay, so this material we can use for so many applications. You can see that for the experiments we are using this material. You may be showing the meter bits. That wire is to be a what, like this wire, and potentiometer. So these materials have independent of temperature. Resistivity is independent of temperature. Okay, so if the temperature increases also, the value will not be changes. Okay, and another two type of materials also there, constant and manganese. What are those? Another two materials also have the same behavior, that is, and one more thing is manganese. These three materials have this same behavior. Clear? Okay. That is the thing about. For this material, what about the alpha value? Sign of the alpha, we have to see it. Okay. So here T2 is greater than T1. What about rho T2? Rho T2 is equal to rho T1 because temperature increases, resistivity is constant. So alpha is directly proportional to rho T2 minus rho T1. So what about this value? This is to be 0. So 0 temperature coefficient. Temperature coefficient. That's it. That is about the temperature dependent of resistivity. And you please take out a note of this. What is this formula? Rho T2 is equal to rho T1 into 1 plus alpha T2 minus T1. I am going to multiply L by A in two sides. That means L by A here and L by A. What is rho L by A at this temperature? This is called as resistance. So RT2, like that I can write. This I will write as RT1. That is 1 plus alpha T2 minus T. Clear? So the variation of temperature also we study. So temperature resistance at T2 temperature is equal to resistance at T1 temperature into 1 plus alpha T2 minus T. Clear? For this case, we have to be taken when the temperature increases, length and area of cross section is to be constant. Clear? That's all about this topic.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.